All right, everyone. So let's go ahead and start talking about 11.2. 11.2 is going to focus in on the law of cosines this time. So we got those other two cases that I showed you in 11.1. They are the side angle side case and the side 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 case. So, cool thing about the law of cosines, we don't have to worry about any ambiguous information. So you don't have to worry about like what we ran into a law of sines where you might have 0, 1, or 2 triangles that could exist for one of those cases. So that's pretty awesome. You've got your notes for this. The law of sines, law of cosines notes that I posted out there. These formulas are a little bit longer, but that's all right. At least we don't have to worry about really any ambiguous stuff. So let's go ahead and start attacking law of cosines. Please know that in this, you're still going to have those application problems where you're going to end up solving for one of the sides or one of the angles in the end. So after I teach you how to demolish triangles, like what we have right here and here, and here, after I teach you that, if you can demolish the triangle, you can do the application problems. Because, again, like I said, you're just looking for one piece, like an angle or a side. The other thing that you'll see in this section is that you're going to learn two new area formulas for triangles. You're going to learn about Heron's formula, which if you know all three sides of the triangle, there is an area formula for that, just by knowing the sides of any triangle, all three of them. And then last but not least, there is an area formula knowing side angle side of a triangle using trig. So that's what's great about the last part of this is you get some new triangle area formulas that existed that you might not have known about. So we'll talk about those soon enough. Let's jump back to the beginning and let's talk about law of sines, law of cosines. Again, law of cosines only works on side angle side and side side side. In 11.1, I've shown you all the pictures of the different types of triangles. Okay, so what they're asking you here is just like what they did in 11.1. They want to know what's the case you've got, and then which one would you use, law of sines or law of cosines? So if I draw in my triangle that I had from 11.1, and I fill in, again, this is still, I let big C represent my largest angle. I let big A represent my smallest angle. B is the middle. And remember that the sides that are across from them. So if this is big A, this side that's across from it, that's little a, which I do have. This guy, as I said, was big C. The side across from it would be little c, but we don't know that guy. This one was big B. The side across from it is little b, and we do have that. So based off of the information that they gave us a side angle side. So that's what we have here, and which would be used to solve law of cosines. And that's what it's looking for. Pretty straightforward, nothing crazy, I promise you. So down here, if I draw another triangle, see what kind of case we have. So that's kind of a horrible triangle. Let me redraw. There we go, a little bit better. So we have a big C, we have big B, and we have little a. So in this case, you've got angle, side, angle, and that was from 11.1. So that's a law of sines. So that's what your first couple problems are going to kind of be like. What case do you got, and then who are you going to use, law of sines or law of cosines? Okay. So let's start demolishing triangles. So if you look at this, you see that you've got side, angle, side. So we're definitely going to use law of cosines to help us out. Now, if you're looking at those formulas for law of cosines, you'll notice that there are three different formulas. One that has a squared equals, one that has b squared equals, one that has c squared equals. But what I want you to pay attention to is the one that has a squared equals. Notice all the way at the end, you have to know what angle A is to use that one. The one that has b squared equals, all the way at the end, you have to know what B, the angle B is in order to use that, because you're going to take the cosine of B. And then the same thing for c squared, you have to know what the angle C is. So when we look at this, we have big angle B. So that's probably a clue that when we're solving for little b, because that's the first thing we're going to have to do, we're going to be using the b squared equals a squared plus c squared minus 2ac cosine b. Okay? Because this guy right here represents little a, or sorry, little c. This guy over here is your little a. Okay? So with all that information, this is the formula we want to run. Because when we start to solve this, when you flip it over and look at our notes, we have 4 cases. Case 1 and case 2, those were for section 11.1, the law of sines. Case 3 and case 4 are law of cosines. And we are in case 3 because we got side angle side. So the very first step says use law of cosines to find the third side. Okay, and that's what we're doing here. We're using law of cosines to find the third side, which is little b. And in order to do that, if we want a little b, that means we have to use the one that has little big B, because that's our angle we know. So let's plug in and let's do some finding. For this rounding, if we need to round, notice everything's kind of nice, neat numbers. Let's round to the nearest whole. Okay, so we have b squared equals 3 squared plus 8 squared minus 2 times 3 times 8 cosine 60 degrees. Okay? So all we're going to do is we're going to go to our calculator. We're going to plug this in. Let me clear all that jazz out there. So we're going to plug this in. So 3 squared plus 8 squared minus 2 times 3 times 8 times cosine 60. And make sure that you are in degrees. My calculator is in degrees. Again, if you're not in degrees, you just go to mode, and then you switch it from radians to degrees by hitting enter once you get the cursor on the degree piece. So you hit enter, and now you're in degrees. Second quit gets you out. And so I've got everything in degrees now. We've got it all in. We hit enter, and there is what b squared equals. B squared is equal to 49. How do we get rid of something squared? Square root. Okay? So b is equal to plus or minus 7. Because when you square root both sides, when you're getting rid of something squared, it's plus or minus. Now, since we're talking about a triangle, though, up here, we're going to ignore the minus and just call it a plus, or just use the positive 7. Okay? I was trying to move the 7 closer, so we'll just erase it, move it closer. So you technically don't have to worry about the plus or minus here because we want the positive. So now we know little b. And so as we continue our steps in case 3, step 2 says use the law of sines to find the smaller of the 2 remaining angles. So my 2 remaining angles are A and C. Well, we know that I always make C the largest angle. So what we want to do then is we want to find angle A. Okay? You want the smaller of the 2 remaining angles. So we're going to use law of sines. And law of sines, we're going to use all the information from B because that's going to be the one that we know the most about. Because law of sines, we're going to make a proportion and solve it. So we got 7 over sine 60 degrees. Okay? And that's going to equal, the length of side A was 3 sine A. And again, we're solving for A because it's the smaller of the 2. If you solve for the other guy, that's kind of creating an ambiguous case where you don't know whether it is that angle or its supplement. So you want to solve for the smaller of the 2. Okay? So we cross multiply. 3 times sine 60 is 3 sine 60. 7 times sine A is 7 sine A divide by 7, divide by 7. Sine A equals 3 sine 60 all over 7. And how do we get the A by itself? We take the inverse. Sine inverse, sine inverse. So A is equal to second sine, there's our inverse, alpha y equals, we've got 3 sine 60 all over 7. Scroll out to the front, close it up. And rounding to the nearest whole, oh, I did it twice for some reason. Rounding to the nearest whole, the 7 says, hey, 1, go up. So angle A is 22 degrees. And then now all you're going to do to find the last angle is take the 60 plus the 22 and subtract it from 180. So 180 minus 60 minus 22. And there is the last angle. Angle C is, what did it say, 98 degrees. One of my wife's favorite bands. And there we go. That's how side angle side works. So go ahead, pause the video, you give it a try. All right. So again, this is the same thing that we just had a second ago. This is side angle side. And we're going to use that law of cosines. So again, we're looking for that little b. Okay, so we're going to use b squared equals a squared plus c squared minus 2ac cosine big B. Okay, so we fill in b squared equals 4 squared plus 6 squared minus 2 times 6 times 4, or 4 times 6, and then cosine 61 degrees. Let's this time round to the nearest tenth. Round to the nearest tenth, because I know this is not going to come out nice and neat. So we're going to come in here. And I'm just going to come up and grab this guy and just remodify. So that's a 1 there. Too far. What was that? A 6 and a 4. 6. Keep going back. 4. Probably would have been faster just to type it out. 6. And one more. 4. There we go. Enter. So rounding to the nearest tenth, the 2 says, hey, 7, stay the way you are. So B squared is equal to 28 point, well, actually, wait a minute, don't round yet. I thought we were at the end. So we want to actually have all of that. 28.7, hey, it's right there at the bottom of my screen. 2, 9, 1, 3, 8, 2, 3. The reason why we don't round yet is because, hey, we're not at the end. This is what b squared is. So how do I get rid of something squared? Square root. Yay. Square root. Square root. And again, we're not going to worry about the plus or minus. All we want to know is the positive value of this. So I'm going to come back here. Second square root. I'm going to scroll up, grab that answer to put in there. And now we'll round. So the 5 says, hey, 3, go up. So B is 5.4. So there we go. And then now we will go through and we will find all of the other two angles by using law of sines. And again, when we use law of sines here, because we want to find big C and big A, excuse me, we need to make sure that we find the smallest angle next. And A is my smallest angle. So we're going to have 5.4 all over sine 61 degrees equals my A value, which was 4 all over sine A. Okay. I don't really like this because we're using a rounded answer here, and then we're going to be rounding again. It kind of drives me nuts. Kind of what would be even better is if we actually just use this number in that top numerator. Okay. So for some reason in the end, your answer is not correct. It's probably because of rounding. So you might want to go back and try using a more accurate answer with more decimals in it for that numerator of the 5.4 and then round it. Okay. So if in the end rounding's off, because again, we're using a rounded answer here. I don't really like that, but we have no other choice. Okay. So if in the end the rounding's off, go back and change this to a more accurate number with lots of decimals from our calculator that we had right there. Just a rule of thumb. Okay. All right. So now we just cross multiply. So 5.4 sine A equals 4 sine 61 degrees divided by the 5.4 because that's how we get rid of multiplication. So sine A equals 4 sine 61 degrees, 5.4. How do I get the A by itself? Inverse sine. So sine inverse, and that's what we're going to plug into the calculator. So second sine alpha y equals, and we have 4 sine 61, close it, all over 5.4. Scroll out to the side, close it, and there is angle A. So round to the nearest tenth, the 8 says, hey, 3, go up. So my angle A is 40.4 degrees. To get angle C, take 61 plus the 40.4, subtract it from 180. So 180 minus 40.4 minus 61. And our last angle, angle C, is 78.6 degrees. See? 78.6 degrees. And there we go. So here is our next example. So obviously you can see this is side, side, side. You've got the steps there. Just make sure that you read the steps. If you notice step 2, or actually step 1, when you're doing this, it says use the law of cosines to find the largest angle. Okay, use the law of cosines to find the largest angle. Remember, the largest angle is across from the largest side. The largest angle is across from the largest side. The smallest angle is across from the smallest side. Okay? So go ahead, pause the video, use that case 4 in your notes, and give this one a shot. All right, so let's dive into this guy. So the first thing it says use law of cosines to find the largest angle. So that means we are looking for C first. Okay? So that means we're going to be using the C squared equal to B squared plus a squared, or a squared plus b squared, it's all the same, minus 2ab cosine c. Okay? So let's fill in what we know. We know that C is 65.88. And since we have to the nearest hundredth on this, that's our decimal place, 2 decimal places, hundredth. Let's round in the end to the nearest hundredth. So your B is the 51.41 squared. Your A, which I always let be the smallest side, plus 37.29 squared minus 2 times 51.41 times 37.29 cosine C. So in this, we're basically going to take all this information right here and move it over there. Okay? So the first thing we need to do is we need to get rid of these two numbers, and I'm going to basically subtract them over to the other side. How do I get rid of a positive number? Subtract it over. How do I get rid of a positive number? Subtract it over. These last three numbers, remember, this is all multiplication. So how do you get rid of multiplication? You divide. Okay? Because I'm going to let the calculator do all the work for me in the end. So again, what I said, we're going to move these numbers over to the other side, because how do you get rid of addition? You subtract it. Okay? So minus 51.41 squared minus 37.29 squared. So what we have is 65.88 squared minus 51.41 squared minus 37.29 squared equal to negative 2 times 51.41 times 37.29 cosine C. Again, all of this is multiplication right here. So how do I get rid of multiplication? Divide. So we're going to divide by negative 2 times 51.41 times 37.29. We're going to divide all this side by negative 2 times 51.41 times 37.29. So cosine C is equal to that giant fraction of 65.88 squared minus 51.41 squared minus 37.29 squared. Let me get rid of this random dots and stuff that appear. That's just my hand touching the screen. All divided by negative 2 times 51.41 times 37.29. How do I get C by itself? Inverse cosine to the rescue. So all of this is going to go in my calculator, and that will tell us what the largest angle will be. Okay? So I'm going to be flipping back and forth between this and my calculator because I can't keep all that in my head. So second cosine, alpha y equals. All right. So we have 65.88 and 51.41. 65.88. Too many fives. Delete one of those out. Squared minus 51.41 squared minus 37.29. 37.29 squared. Make sure of that. Yep, 37.29. And then all over -2, 51.41, 37.29. All right. -2, 51.41, 37.29. Again, let that calculator do all the hard work for you. Close it off. And this will tell us what our largest angle is. And boom, there it is. Since we're rounding to the nearest hundredth, the 7 says, hey, 8, go up. So 94.59 degrees. There is our largest angle. Cool. So the next step says use law of sines to find any of the two remaining angles. So we can either find angle A or angle B. Okay. Again, it's going to make us use a rounded answer for that angle C. You know, again, if you have rounding problems at the end, excuse me, yawning. Just go back into the calculator and use this accurate number. Okay, there's nothing wrong with that. All right. So we definitely know that we're going to have the angle C information. So C, side C was 65.88. And we have, it's not cosine, law of sines, Mr. Armstrong. Sine 94.52. I'm going to go ahead and solve for the smallest angle. So I'm going to solve for angle A. I could have solved for angle B. It's all the same. So angle A, and I'm going to put in 37.29. Okay. So 37.29 all over sine A. And we all know how this is going to work. Cross multiply, you get 65.88 sine A equals 37.29 sine 94.52 degrees. Put degrees in here. Divide by 65.88. Divide by 65.88. Sine A equals 37.29 sine 94.52 degrees all over 65.88. How do I get the A by itself? Inverse trig, sine inverse, sine inverse. And this is how I will find angle A. And then you could also, if you wanted to, go in and find angle B. All you got to do is replace that with the angle B number, which was the 51.41. So after you do that, you can just go right back in and replace that with 51.41. And that will tell you angle B. Or again, you could just add up the two angles, the angle you get for A, the angle you get for C, and then subtract it from 180. So let's find A real quick. So second sine alpha y equals. So we have, make sure on top, 37.29. 0.29 sine 94.59. And on bottom, we have the 65.88. Let me double check. Yep. Hit enter. And there is angle A. 34.35, because the 7 hit says, hey, 4, go up. 34.35. And again, to get the last one, degrees, of course, to get the last angle, you can add these two up, subtract from 180, or you can just go back in and run this, but change this 37.29 to 51.41, which that's what I'm going to do real quick, because I like to try and be accurate as possible. So this is, go back, 51.41. And there's the other angle, 51.06 degrees. There's angle B, 51.06 degrees. And if you add all three of those up, it should be 180 degrees. And there you go. That's law of cosines. And again, like I said, you'll have some word problems that are like that. But you're not demolishing the whole thing. You're just looking for a single piece. So that's not too bad. You just, run a part of it. Okay. So like I said, the last two things you're going to see are area formulas. I don't have any examples for these because all this is a plug and chug. Okay. So we could actually go back and use this example that's right here and actually find the area of it using Heron's formula, because Heron's formula works for side, side, side. Okay. So here's what the formula looks like. You have this thing called a semi-perimeter. Okay. Semi-perimeter just means take and add up all three sides and then cut it in half. Okay. So that's a semi-perimeter. Take and add up all the sides and cut it in half. And then down here is the formula that you'll run. You'll take the square root of the semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. And that's it. There's your area formula. It is a simple plug and chug. So if you are finding the area of a triangle and you've got all three sides, this is the formula you got to use. Find the semi-perimeter first, and then you plug in. Okay? I'm not going to do an example of this. It is just a formula. You plug into it. Okay? And the same thing for the last one. It's just a formula. This is what the formula looks like. The area is equal to 1/2 the side 1 that you're given, the second side that you're given, and then cosine of the angle between. So it's side, angle, side. So again, we could go back to these triangles right here, and this is a side 1, this is a side 2, there's the angle between, and we could find the area for it. But I'm not going to insult your intelligence. I'm not going to run. All this is just a formula. I think there's like 1 or 2 of these problems with the areas. Okay, one where they give you the Heron and one where they give you the side, angle, side. All you do is you plug into it and you kick out an answer. Make sure that you round accordingly. Also remember that all area labels are squared. So if the sides are measured in inches, the answer is inches squared. If the sides are measured in miles, the answer is miles squared for area. Okay? And that is 11.2. Enjoy.